So what is Thevenin theorem? You already know, right? To calculate Thevenin theorem for normal circuit, for a DC circuit, you already know where there were only resistive elements. But now we are talking about an AC circuit. That means there will be a particular frequency. This frequency, understand this experiment. If you were in campus, you would have done this in the energy conversion lab, which is the adjacent lab to basic electronics. Okay, which is a electrical lab, like core electrical lab. So you would have done this experiment actually on a variac. Instead of using a function generator, you would have used a variac. What is a variac?
Variable AC source.
Variable AC source, right? So it's high voltage. It can go up to 220 volt. Your function generator cannot go more than, I think, 20 volt. So variac will be your source. It would have been your source, right? Instead of using a normal resistance, we would have used rheostat. And if you have completed the previous video on familiarization with electrical circuits, you know rheostat is nothing but variable resistance. And the one that we have in our lab, the full value is 290 ohm. If we were not using it variably, if we were using it end to end, it is 290 ohms, right? And then inductors would be like in big boxes instead of being small elements. And capacitors will also be in big boxes as opposed to the small, Tinkercad mein how you're used to seeing ceramic capacitor or electrolytic capacitor. They are different, right? So these are huge elements in the electrical lab which have much higher power rating. They are meant to work at 220 volt. Till now, all the equipment we were seeing in the lab, we were using it at 20 volt, 15 volt, these things, right? Those were electronic components. So this is a major difference. But since you are still going to do this on Fallstadt simulator, nothing much changes for you, right? But it is important for you to understand and correlate these things with the electrical lab and no longer associated with electronics lab. Now the circuit is very simple. Question is what? Question is that you need to find Thevenin equivalent of this circuit which is given, right? So finding Thevenin voltage should not be a problem at all, because you just need to connect all this, connect the circuit like this, and you know that VTH is nothing but V open circuit. Like if you're finding across these two terminals, all you need to find the open circuit voltage, like current voltage. Take a voltmeter or multimeter, put it across these two terminals, and that should give you the value. If this was a resistive circuit, everything was okay. Directly values could have been taken. But since this is an AC circuit, all these terms are actually phasors, right? So here again comes another difference between what you would have done in lab and what you will observe here. On Fallstadt, how will you measure the voltage here? You will connect a voltmeter probe. This voltmeter probe is not going to give you one value. It is going to give you instantaneous values. Means it is going to give you a waveform. However, if you were doing this experiment in lab, you would have used a multimeter. And the multimeter would have given you only one value. It would give you only one value at any given time when you were measuring. And that value is nothing but the RMS value. Okay, so you would have put your multimeter in AC mode. And when you would have put your multimeter across these 2 points, it will give you one single reading. And that is what would have been RMS value. But since you are doing this on Fallstadt, please understand, you don't have multimeter on Fallstadt, right? You only have a tool to measure voltage. And when you add that voltmeter probe over here, it is going to give you a waveform, not one single value. So it is important that you plot this waveform and then view its which value?
RMS value. RMS.
Okay, the same thing is for the input. The input is a 150 volt 50 hertz signal. That means when you make it on false start, it is single phased. Okay, so there are no multiple phases which have phase difference between them. Don't have to worry about that. So what you will do is peak value you will set as 150, frequency you will set as 50. Now here again, V input का मैग्नीट्यूड लेने के लिए आपको क्या करना पड़ेगा?
रूट 2 से डिवाइड करना पड़ेगा।
150 नहीं ले सकते, राइट? सो you can directly divide it by root 2 or just plot it. Note the RMS value, because RMS value वहां पे लिख के आती है, right, waveform में. That is going to be your mod Vin, and the RMS value across this point, that is what is going to be your VTH. Okay, now there are 3 subparts to this problem, to this experiment, but it is okay if you do not do the last one. I'm keeping the last one as optional. Okay, so essentially, I'm sorry, this should be angle. These are angle symbols. If it is not appearing correctly in the manual that I have uploaded, I'll fix this. Okay, these are meant to be angle. So what are the 3 parts? Measurement of VTH, this we have discussed just now. This is very easy. The only thing is, keep in mind that while measuring on false start, you need RMS value, not instantaneous value. Okay. Second thing is measurement of ZTH. Thevenin equivalent voltage आ गया, अब Thevenin equivalent resistance या impedance निकालना है. You know that ZTH itself is a phasor which has a magnitude and an angle. Okay, how to calculate this angle I have discussed in the video. I'm not covering it right now, but this is optional. This third part is optional. Okay, you do not need to do it in the lab. Only if you want to experiment further, you can do it, but this is not a part of our lab experiment. You need to do compulsorily only till this part, step 1 and step 2. Now, step 2, mod ZTH. Why we could not have simply normal circuit होता तो आप इसको शॉर्ट कर देते, ओपन वोल्टेज सोर्स को शॉर्ट कर देते, तो ये भी हट जाता एंड ये भी हट जाता, right? But because these are phasors, AC quantities, we cannot just short out the source like this and just simply put a ohmmeter over here and measure. So what we will have to do is, we will still have to give some source. That is why there are the same logic also holds for a circuit where all independent sources are disabled. If this was a circuit, if I disable all independent sources within this network, and now I give an external test voltage to it, and because of this external test voltage, some test current flows through it, then I know that RTH is nothing but V test upon I test, right? Because it is as if in दो terminal के across आप equivalent resistance ही देख रहे हैं. Here, however, instead of RTH, it would be ZTH, right? Now, another thing to understand here is, when you are making this on false start, so what kind of circuit are you making? वो source or inductor तो short out हो गए because of disabling the independent sources. So you are only remaining with this. When you try to connect this kind of a circuit on false start, so you have this as the peak voltage, you will connect an ammeter to measure the current in the magnitude of the current. Here again, magnitude of the current नहीं, RMS value of the current चाहिए. ये जो भी आपने voltage लगाया, इसकी RMS value चाहिए. Okay, V test. So mod of V test will be the RMS value of this 100 volt, and mod of I test will again be the RMS value of this. Okay, don't forget to plot this while calculating the RMS value of the current. Note that if you do right click on this element and plot it, what will it show by default? It will show the voltage value, right, on false start. So it will show the voltage across this ammeter. That is not what we want. We want the current through this ammeter. So आपको settings में जाके voltage uncheck करके current check करना पड़ेगा settings में, right? Then you will see the current in this branch. उस current की आप RMS value note करेंगे. That is your mod I test. Now, one important thing which will where you will face a problem in false start is when you make a connection like this, it will not accept it only. It will say that capacitor or source के loop में एक resistance होना चाहिए. It will not work. So just on false start, if you were doing this on in the basic electrical lab, this would work perfectly fine. Okay, but for false start, what you will need to do is just to like convince false start that no, we have a resistance. You will need to connect a very small value, maybe 1 micro ohm, या फिर 1 milli ohm. Okay, very small value. ना के बराबर value you will have to connect over here just for the sake of false start. It will hardly, because the value is so small, it will hardly have any effect on the current value, right? It's almost as if it's a plain wire. It's a very small value. This is an important thing that you need to remember while doing this experiment. On false start, for this case, you will have to take a very small resistance, otherwise it will not work. Okay. Then, of course, you can see that to actually find the value of mod ZTH, this value and this value's ratio is all that has to be taken. Okay. These were all measured values. Please understand this. These are measured values. You have to fill an observation table here with experimental values and theoretical values. So experimental values कैसे calculate करनी थी? This I have told you right now. Right? And what you will be careful about? You'll be careful about measuring the RMS value. And because we are using false start, you will make sure that you plot the waveform and then note RMS value from it. क्योंकि waveform में दिखता है. अगर नहीं दिखता है तो just go to the setting and enable RMS value. So you need to write here when V test was 100 volt. जब आपने यहाँ पे 100 volt का V test दिया, तो mod V test क्या था? That you have to write. Okay, and at that time I test की value मतलब mod value क्या आई? Measured value ammeter की. That also you have to write. This will most likely be in milliampere. So you please be careful about the units. Okay. Second very important aspect of this experiment is that you need to show the theoretical calculations. Measured values तो ठीक है, कैसे आपने measure किया, उनके screenshots वगैरह लेके you will put it in the report. Please make sure, another very important thing, your screenshots should contain readings, मतलब cursor readings. Because for this experiment, you do not have to make any Tinkercad schematic. You do not have to make any video either. But you need to show detailed calculations in your report. Abhi tak we used to ask for just 1 or 2 calculation. Here you have to show both these detailed calculations properly. And since you don't have a Tinkercad schematic or a video, the screenshots that you are inserting here in the report should contain the cursor reading. Cursor reading से मेरा क्या मतलब है? ये जो भी आप ये whatever these things you are claiming, right? These values, ये सब दिखना चाहिए waveform में. It should be visible on the waveform from where you took this reading. Okay, this is one thing. Also insert the circuit diagram directly from false start, so we will be able to see that what was the value of the resistance you took. Now coming to theoretical calculations. Okay, this is very important. Please understand that all calculations that you're doing are in phasor. I cannot emphasize on this enough. This is 290 ohm. This is 2 Henry. This is 10 microfarad. And this is 150 volt, 50 hertz. Right? Now, in the very first step. So theoretically speaking, V in the input voltage that you are giving, how can you write it in the form of a phasor? Angle 0 degree, right? So theoretically, अभी यहाँ पे सब कुछ theoretically है, तो mod V in क्या होगा? This value, right? This will come out to be how much? Approx?
107.14.
107.14. Okay, so please calculate this yourself, and this will be your theoretical value of V in. Okay, next, now if we were talking, note that frequency is 50 hertz in both the cases. जब आपने ये रखा था या आपने इसको डिसेबल कर दिया था and you connected a V test, right? V test में भी this is also an AC waveform. The only thing was its peak value was 100 volt and frequency was still 50 hertz only, right? Because this would have been, your source would have been your variac, right? And variac directly works at 50 hertz. आप केवल voltage change कर सकते हैं, variac का frequency 50 hertz ही रहता है. Okay, so frequency is 50 hertz only. So understand that for the second case, you should write down what are the values of reactances. Yeah, even in the first stage itself, because frequency is 50 hertz, reactances, right? So XC will be something, R will be something, XL will be something. So what are these values? XC, again, abhi I'm not interested in the phase values, but just mod point of view say. XC would be what?
1 upon omega c.
1 upon omega c. That means 1 upon 2 pi f this, right? What will be this value? Something. R is R only. This is 290 ohm. So this will come out to be something in ohm. Please calculate that value. XL ka bhi mod is omega L. That means 2 pi f into L, which will be something ohms. Okay. Calculate these correctly, please, in your calculations. I'm not going to show you the answers right now, but these are going to be some values. Okay. Now, how do you calculate the theoretical value of VTH? Is terminal के across open circuit voltage.
V in into our resistor pan मतलब resistor plus capacitor का जितना.
Right, because this whole thing is coming across these two terminals. So essentially, it is like this whole voltage is coming across these two elements. So now you need to just find what is voltage across 290. So it will be V in into 290 upon 290 plus XC, right? So VOC would be, how can I write this? I can write this as, अब यहाँ पे कैलकुलेशन करते टाइम बहुत ध्यान रखना है, आप सीधे सीधे मॉड वैल्यूज उठा के नहीं रख सकते. ये जो आपने ये वैल्यूज जो कैलकुलेट किए हैं डायरेक्टली ये उठा के नहीं रख सकते क्योंकि एंगल बहुत इंपॉर्टेंट है. ओके क्योंकि एक्चुअली एक्सी क्या था? 1 upon j omega c, right? That means some value angle minus 90 degree, some value angle minus 90 degree ohm. That is what XC was. R was okay. R was just R. तो आप लिख सकते हैं 290 angle 0. These are phasors, not magnitudes anymore. Again, XL would have been what? J omega L. That means this thing, angle plus 90 degrees. Right? Now, because you are saying that to calculate theoretical value of VOC, which is just voltage across 290 ohm, I need R and I need XC, both. So I cannot just take XC ka magnitude. While doing the calculation, I have to take its complete phasor representation. That means VOC can be written as V in, again this is phasor, R angle 0 upon R angle 0 plus ये जो भी value आई थी, let me call this as mod XC, right? Mod XC angle 90. So mod XC angle 90 degrees. This is my input. और V in भी क्या है? V in आप लिख सकते हो, right? 106 something or 107 something. So mod V in angle 0. This calculation is what you need to do. Okay, because यहाँ पे denominator में there is a plus 90 degree. Sorry, this should have been minus 90 degree, right?
Yes, ma'am.
Minus 90 degree, right? This phasor computation is what you need to do. If you just did it r upon r plus mod xc, you would have got the wrong answer. It will not match with the actual VTH जो आप measure कर रहे होंगे, उससे match ही नहीं होगा. All the polar representations while calculation need to be converted to Cartesian. एंड देन कार्टेशियन में आपको पता है कि सारे रियल एक साथ आ जाते हैं, सारे इमेजिनरी पार्ट एक साथ आ जाते हैं, एंड देन इवेंचुअली जो भी आंसर आता है उसको वापस से आप पोलर फॉर्म में लिख देते हैं, राइट? सो इट इज वेरी इंपॉर्टेंट दैट यू डू दिस स्टेप करेक्टली. एंड व्हाट इज द सेकंड थिंग दैट यू नीड टू फाइंड थियोरेटिकली? ZTH. सो ZTH क्या होता थियोरेटिकली? सो फॉर ZTH you are essentially looking at this kind of a circuit. So I should write it 290 angle 0, and this is mod XC angle minus 90. So now what is ZTH? ZTH would be the parallel combination of these two, Z1, Z2 upon Z1 plus Z2. That means nothing but mod XC angle minus 90 into R angle 0 upon plus R, right? So ऊपर तो केवल multiplication है and there is only angle 0. So this is essentially the calculation you need to do. Okay, this is complete. So इसमें angle भी है, but you only need mod ZTH. So then when you calculate this whole thing, just find, इसको आपको simplify करना पड़ेगा, right? Eventually numerator, denominator. Then whatever you are left with, उसका magnitude आप लेंगे. Please make sure that you do these calculations correctly. Then only your theoretical values and your measured values are going to match. Because ये values आपको यहाँ लिखनी है, and like it is said, you need to show the detailed calculations. Like how I have shown, I have not written the values, but these need to be shown. So इसको आपको simplify करके लिखना पड़ता, something upon something. Then finally you have to bring it in this format. इस फॉर्मेट में आपको लाना पड़ता और आप कहते ओके सो दिस इज मॉड ZTH. आई कैन टेल यू ये वैल्यू आनी चाहिए लगभग 214 ओम्स के आसपास या 214.5 ओम्स के आसपास. ओके, बट आपको शो करना पड़ेगा क्योंकि आपको एक्चुअली लाना पड़ेगा उसको इस फॉर्मेट में, एंगल भी लिखना पड़ेगा. फेजर कैलकुलेशन करने की प्रैक्टिस आपको करनी पड़ेगी, ठीक है? For example, 10 angle 0 upon 10 angle 0 plus 50 angle minus 90. इसको कैसे solve करेंगे? This is just 10 plus 0j. This is just 10 plus 0j plus 50 angle minus 90. How can we write this? So would this be minus j50? Right? So cos 90 is 0. And cos minus 90 is 0, and sin minus 90 is
minus 1.
minus 1. Right? That is how it became 50 into minus 1j minus 50j. अब इसको आपको कैलकुलेट करना पड़ता, राइट? न्यूमरेटर इज ओनली वन वैल्यू, बट डिनोमिनेटर का आपको मैग्नीट्यूड निकालना पड़ता, 10 स्क्वायर प्लस 50 स्क्वायर, एंड एंगल हो जाता माइनस tan inverse of minus 50 by 10. Right? This would be in the denominator, but then it will go up and then it will change its sign. The angle will change its sign. ऐसे करके आपको final magnitude और वो निकालना है. This was just an example. You can cross check your work with the phasor calculator online. This is the VTH wala case, right? So I have taken, this is my input waveform. and I can see that its RMS value, so V income mod is 106.033. Okay, this should be same as 150 divided by root 2. Now this is input. VTH is what I'm measuring here. I have added a voltmeter probe. Now when I view this is a waveform, right? I'm not getting one single value, but is waveform ka RMS value I should note down this value, right? 71.41. So your mod VTH should match this value. Okay. Now the second part. Now I am required to give a eye test, right? V test, sorry. V test की max value होनी चाहिए 100 volt. Okay. Now when I connect, oh, I need an ammeter also, right? Okay. It says capacitor loop with no resistance. It will not give you anything. यहाँ पे आपको लगाना पड़ेगा एक छोटा सा resistance. Now it is running. So now what do I need? I need V test का magnitude. V test का magnitude है something like this. And I need I test. I test की current value I need, right? So when I view this, essentially this is just showing me voltage across ammeter. This is wrong. I need to go into settings, remove show voltage and enable show current. Okay, this value will not work. Maybe this value is too small. Let me use 1 milliohm. Reset. Okay, don't use 1 micro ohm. Okay, use 1 milliohm only. Now this is current value, right? And I can see what is the peak value and I can see what is the RMS value also. This value, the RMS value is what is going to be, it is in milliampere. This is what is going to be my mod I test. Okay. And the ratio of this is what is supposed to give me mod ZTH. That should match the theoretical value of mod ZTH that you calculate.